We're disappointed that we can't attend the conference, but glad to have this opportunity to tell you about what's been happening in CycDesign. CycDesign is a program that can generate a wide range of experimental designs, and it's focused on producing designs that can be used in practice. In particular, 5 different types of design are available, that is, resolvable, non-resolvable, multi-location partially replicated, in other words PREP, single-location PREP, and crossover designs. Apart from the last type, the designs can be arranged in blocks or in rows and columns. CycDesign version 7 was released by VSN earlier this year, and the next slide lists the main features. A major development in version 7 is that we can now construct spatial designs along neighbor balance and evenness of distribution principles. These designs are proving very popular in practice and are designed to minimize the clustering of treatment pairs and replications. This is something that does cause users concern, and it can arise in the standard randomization process. While randomization is important to protect against error variance bias, analyses have shown that any resulting bias from the use of neighbor balanced or evenness of distribution is small. We can also construct single location PREP designs, and we provide GenStat and SAS code for all spatial designs. The ideas are illustrated in this example that comes from a maze trial in Germany. With the normal row-column randomization, some treatment adjacencies can arise that users would prefer to avoid for a number of reasons. For example, patches of poor productivity or environmental stress may affect particular treatments, leading to a neighbor advantage for other treatments. For example, in the slide, treatments 8 and 32 appear twice as row neighbors. Treatments 21 and 31 have replication as single diagonals. Treatment 8 only spans 4 of the columns, and treatment 10 spans just 3 of the rows. On the next slide, we show a neighbor-balanced and evenness of distribution design for the same parameters. It avoids all the treatment adjacencies that were shown in the previous slide and has minimum column and row spans of 8 and 6 respectively. There's a small drop in the average efficiency factor, but that's outweighed by the advantages evident in these new designs. The construction of single-location PREP designs is an important addition in CycDesign 7. Here's an example for 62 treatments, of which 24 are duplicated. Users can specify these parameters and also choose to include standard treatments in the design. As such, these designs can be viewed as a combination of straight PREP designs and what are known as augmented designs. We can also opt for spatial improvement for the duplicated treatments following neighbor balance and evenness of distribution principles. Here, the minimum column and row spans are 6 and 5 respectively. If you want to know more, here are some recent references. The first one gives the underlying theory. The second evaluates the degree of error bias resulting from the randomization restrictions invoked by the designs. And the last reference is a tutorial-style paper giving examples from practice. So we hope that you'll take up CycDesign 7 and make good use of the new facilities.